Okay, Assalamualaikum. Welcome back to my channel. So, today we are going to discuss in chapter 7 about structure and bonding for ACS exam preparation. Okay, so um, as I mentioned in the previous video, we already discussed like much more detail about what else, what's the name, enthalpy and heat. Okay, now we are moving to another chapter which is about structure and bonding. So this one is quite a bit tough, right? Because we will cover much more detailed information about lattice energy, electronegativity, structures, then formal charge, resonance, bond enthalpy, bond length, bond strength, molecular shape, geometry, polarity, valence bond theory, molecular orbital theory, and then other stuff. So, first of all, I want to let you know that uh, when we are discussing something, it's better to give like kind of like the concept first, and then we are tackling the equation. Okay, so while needless to say, so let's get started. Okay, so now we are doing for the first part. Okay, what is the order of CSCN, MgO, ClC, CaCl2, and NAPR in order of increasing magnitude of lattice energy? Lattice energy. So, okay, let's let's build the concept first before we are going to discuss. Okay? So the main thing to remember is higher charge and smaller ion give you higher lattice energy. Okay? Just remember that lattice energy, okay, let's build the concept. Lattice energy. Okay? So lattice energy is the energy. What is the lattice energy? Is the energy released when ions, okay, when ions come together to form an ionic solid. I repeat it again. The energy released, okay, when ion come together, okay, come together to form an ionic solid. Okay? So there are two main factors. The magnitude depends on two main factors. Okay? The magnitude depends on two main factors. Okay, the magnitude depends on two main factors. What's the first factor is charge of the ion. Charge of the ion. Okay? Higher charge also increasing the lattice energy. And then the second one is size of the ions. Okay? So smaller ions will give us like higher lattice energy. Okay? Because of the lattice energy using the equation using lattice energy is Q1, Q2, and then R square. Okay, Q1, Q2 is charge, and then R itself is a radius. So based on this equation, we will see that which one that has a lower radius or lower size, it will be higher uh, magnitude of lattice energy. If those have a lattice, like those have a like higher charge, it will be higher lattice energy. Okay, so in this case we have kind of like a equation for each one. Okay, let's take a look at one by one. Okay, first of all, we are dealing with the one by one. Was that one by one of the option CA? For example, SCN. Okay, SCN. SC, it has 3 plus and has 3 minus. Okay, and then put is small. Put are small. Okay, and then how about the MgO? MgO is Mg2 plus. Okay, and then O2 minus. Okay, both are also small. How to know this one is small or large? Just you looking at the periodic table, and then as you can see that if we are looking at the periodic table, when we are uh going to right, okay, the radius will be decreasing. Okay, the radius will be decreasing. Why? We have like much more proton. Okay, we have much more proton, and then it will pull towards the center, so it will shrink the radius. Okay, all right. So SC and then N in the periodic table, in the, let me check it first, periodic table in the right one. I'm pretty sure O is the in the right. Okay, I just want to take a look at a group. Okay, group 16, right? In the group 16 for O, and then for SC in the group 3B, and then N in the group was that the 15. Okay, so both are still small. Okay, and then let's take a look at for others. Let's take a look at for others. How about the CaCl2? CaCl2. Okay, CaCl2. Ca is 2 plus, Cl is minus. Okay, okay, so Cl, okay, Cl is bigger than N and O. Okay, Cl is bigger than Cl and O. Okay, Cl and O. Sorry, Cl is bigger than O and N because it has much more subshell. Okay, it has more shells. Okay, so that's why Cl bigger. All right, and then Okay, all right. So Cl is bigger than N and O, right? So if bigger, it means the lattice will be decreasing. Okay, and then now the last one is Na and then Pr. Na plus and then Pr is minus. Let's take a look at for Pr. Pr is bigger than Cl. Okay, so based on this information, we can like we can understand okay, we can understand why so the lowest one, okay, the lowest one is NAPR, like I mentioned, because PR is the biggest one. Okay, because both ions are large and then it also singly charged. Okay. Okay. Okay, so if the chart is smaller, okay, if the chart is smaller, it will be stronger. If the chart of the ion is higher, it will be like more a stronger like attraction, and then it will be causing the lattice, like it will be producing the higher lattice energy. And this the size of ion, if both are close together, if the smaller, if like imagine if you have much more charge, okay, of the ion, it will be what, it will be like it has it, for example, 2 and 2 and 3 and 3. uh so 3 and 3 will be stronger than rather than 2 and 2, right? 2 and 2 is smaller. 3 and 3, it will be stronger attraction. Okay, so it will be having higher lattice energy. Okay, how about the size? If the size is smaller, okay, it will be much more close together. Okay, it will be closer together, so it will be having the stronger attraction and then causing the higher lattice energy. So based on this information, the thing that we need to considering is Mg and then Cl, because Cl and Ca is 2 plus, Mg 2 plus. However, Cl much more bigger rather than O and then N. So, like I mentioned, NAPR will be the smallest one, and then CaCl2 will be the second one, and then MgO will be the third, and then this one is will be fourth. So the answer will be NAPR, CaCl2, MgO, and then SCN. Okay, will be C. The answer will be C. Okay, just remember this concept. Okay, just remember when comparing lattice energy, higher charge, okay, higher charge and smaller ions means a bigger lattice energy. Because of what? Like I mentioned before, it will cause the like stronger attraction. Okay? And then now we are going to number 2. The electronegativity of C is 2.5 and that of F is 4.0. What is the best description of chemical bond between these two elements? Okay. So, what we want to know for to determine the electron, first step is find the electronegativity difference between both elements. So both element will be the electronegativity is will be 4 minus 2.5. So the electronegativity will be what? The difference will be 1.5. And then now there is an information, but it's quite possible there is no this information in our book. I mean in the ACS exam. So just remember that the ionic bonds Okay, in general, the difference will be 2.0. And then for polar covalent bond, polar covalent, it will be around 0.4 till 1.6 or 2. Okay, or 2. Okay, and then there is another thing is non-polar. So ionic more than 2.0, polar is in between 0.4 till 1.6 or 2, and then non-polar, it will be less than 0.4. Okay, and then as you can see, uh there is also metallic bond, which is not relevant because C and F is gas. Okay, so based on this information, we can see that the difference, because like around in this range, so it will be polar covalent bond. Okay, so yeah, so based on this information, all right, so let's move on to another question again. All right, what is the formal charge of the nitrogen in nitric acid? The formal charge. Okay, the formal charge. So remember, formal charge is different with the redox, I mean the oxidation state. Just remember that one, because sometimes we are like getting confused, like which one that we need to which one, what's the meaning of the formal charge. Okay, now the concept of formal charge. The formal charge is the concept of formal charge is valence electron minus non-bonding plus half bonding electrons. Okay, now what we need to do is we want to take a look at what's that, the we want to take a look at, let me, a Lewis structure. Okay, Lewis structure first. Okay, we want to know the Lewis structure. Okay, how to draw that the Lewis structure of HNO3. Okay, HNO3. Just writing down first, N O O O, kind of like this. Okay, and how many? In N is 5, so it will be kind of like 5 put in over here, here, and here. Okay, we will have kind of like this one, so O will be 6, right? Let's take a look at first. Okay, so and then it will be, oh, sorry, so I'm getting confused. Why this way I'm saying like NHN? Okay, it will be kind of like this one. Okay, and then yes, something like this, right? And then this one is just 4, right? Yes, it is. And then H over here. Okay, yeah. sometimes we are getting confused to to build of the, was that the Lewis structure. Okay, so one H attached to hydroxyl group, that O attached to N. Okay, and then A N also double bond. So typically N is the central atom because it's connected like 3 oxygen and then one which attached to H. All right, now let's take a look at like the valence of electron. Okay, so regarding this information, the valence electron of N, we need to determine first which one that the like the central atom. So N is central atom over here, right? It has 5, okay, 5 electron. And then how many non-bonding electron? We just focus on in the central atoms, okay? Non-bonding 0. Everything bonding over here, right? And then plus half bonding electron. So 8, we have 8 electron bonding here. Okay, 8 electron bonding here. Okay, non-bonding plus half bonding electron. So bonding electron N is part of 4 bond electron total. So the total here is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 electron divided by 2. So it will be 5 minus 4. It will be 1. Okay, it will be 1. Will be 1. Number 3 will be 1. Yes, that's true. So the thing here, we need to get a good Lewis structure first, okay? All right. So now, again, we want to take a look at how many lone pairs are on the central atom of ClF3. ClF3. Okay, lone pairs. So remember F. How many F we have over here? F, it has 3. Okay, F over here is 3. So first of all, count valence electron. Okay, Cl, okay, for Cl itself, okay, has 7. Okay, 7. How about the F? F also have 7. Okay, so the total electron, however, over here is 3, right? So the total is 28 electron. Now, Cl is central, okay, bonds to F, all right, and then assume we have 7, right? 7, so Cl, and then 1, 2, 3, 4, 5, 6, 7. Okay, it will be something like this. Okay, how many lone pair are in on the central of atom? Okay, just kind of like this one first. Okay, now let's take a look at F. So we can kind of like place it over here because it has a 7 as well, right? And then we can draw just kind of like this one also F, right? So this is the thing that we need to consider. We need to like rethinking like where the best place for each F. Okay, now we already removed 2 electron from here and here, and then just place it over here. So it will be 2 lone pairs on the central atom. 2 lone pairs on the central atom. Okay, just remember. Okay, and then but this is the lone pairs. Okay, this is the lone pairs. So if the question is about formal charge, formal charge is 2 over here, right? So the formal charge, like valence, which is how many valence electron over here is 7, right? And then how many non-bonding? How many non-bonding? Non-bonding, 4, right? And then how many like half bonding electron? 1, 2, 3, 4, 5, 6. So 6 divided by 3, so 3. The formal chart of Cl is 0. Okay, the formal chart of Cl is 0. So with all formal chart equal to 0, the structure is reasonable and the lone pair chlorine is 2. If you like difficult, just draw for the Lewis structure and then you will be good. Okay, so next, for the next question about what is the resonance structure for the molecule is shown. It's quite is a little bit tricky for this part if you don't understand what can I say, if you don't understand the concept of resonance itself. Okay. So resonance structure is alternative Lewis structure for molecule that has the same range. So analyze the let's take a look at for the first the structure. So we have structure kind of like N, okay, and then O, O, N, C, O, O, right? All right, so now focus on oxygen. Okay, focus on oxygen here. All right, so now let's take a look at first. So you can see from the question that you will need to know the definition of resonance structure. So resonance structure, two or more structure are resonance structure when they are the same molecules. Okay, there will be resonance when they are the same molecules. Okay, same molecules. We need to take a look at which one that's same. Okay, they must be have the same formula. Okay, they must have the same formula. All right, so another one, number 2, you have to have only the electron can move. Okay, electron move, not the atom. Okay, not the atom, so only electron can move. Okay, number 3, they must be reasonable structure. Reasonable structures. Okay, to determine, you will use the formal charge. Okay, remembering that structural with the formal charge close to zero are more reasonable. Okay, so formal charge 0 is reasonable, close to 0 is more reasonable. Okay, when a formal charge cannot be 0, the more electronegative atom will have a negative formal charge. Okay, and when formal charge cannot be 0, the more electronegative atom will have a negative formal charge. Okay, so okay, now we can, using this criteria, we will ended up eliminating, we can ended up eliminating some of structures. Okay, so first of all, let's take a look at the molecules. Okay, so NNCOOO, and then we can eliminate one by one. Which one that not same molecule? NNCOOO, this one is same, this one is same, A same, B same, C, it doesn't make any sense because there is a C. like there is change over there. So how about the D? Yes, it still makes sense. All right, now let's take a look at for uh criteria number 2, electrons move. Okay, electrons move. Okay, how about the E? Yes, electrons move. How about the B? Yes, electron also moving. How about the D? Yes, it also moving, I think, right? Okay, but we need to remember that N always have 5. Okay, always have 5. Should be always have 5. Let's take a look at one by one. N here, 1, 2, 3, 4, 5. Okay, let's see. N is always 4. Let's see for the periodic table. N is 7, so 2 and 5, right? So it will be 5, right? However, where is the yeah. So you can also eliminate the structure uh because of N. Okay, let's take a look at for N. So as you can see, N here is 4. This one also 4. Okay, 1, 2, 3, and then lone pair 4. And then let's see. This one 1, 2, 3, 4, 5. Hmm. Expand its octet and make five bonds. It cannot make 5 bonds. Yes, it cannot make 5 bonds, right? It's only can make 4 or 3 bonds because we need to have a lone pair, right? We have to have a lone pair. So we can eliminate this one because this one it has 5 uh because in this part it has 5 bonds. So it doesn't make any sense, I think. Okay? It doesn't make sense for the option A, 5 bonds. So let's open the slave structure. Oh, it's only 6, right? Oh, it only 6, so it doesn't make sense for this one. Okay, so it should be something like this. It doesn't make sense. Okay, so not reasonable structure, so we can eliminate the A of option. Remember, we have the option, so we don't need to remember like we don't need to kind of like look at in detail for the question. We just look at detail for in the option. Okay, if the option kind of like not make sense, we can eliminate it. Okay, how about the B and D? Okay, this one is makes sense because N will be something like this one, and this is a X, right? I just put in here X. This is for the option D first. Okay, XX, and then it has, I think it has uh over here X. Really? Hmm. Hmm. Oh, O is 4, right? Let's take a look at first for the option D. Okay, for the option D. I'm just wondering, like, what's the answer of this one? Uh, s- okay. Let me. Apa? So delta H reaction is total energy for to break bond, energy to break bond, minus to form bond. So breaking bond is reactant. So breaking bond is reactant. Oh, forming bond is product. So I think I make a mistake over here, guys. Remember, I'm so sorry for this one. Okay, the enthalpy change for reaction using bond energies. We need to know this one is reactant, right? And then this one is product. Because in the reaction, we need to know total energy to break a bond, okay, to break bonds, and then total energy to form bonds, okay? So based on this equation, okay, broken and then form. Broken is in the reactant, form is in the product. Okay, so you break a weaker bond than you make, so the reaction release energy, so exothermic. So based on this question, based on this answer, okay, we break weaker bonds. This one is weaker bonds to make stronger bond. Okay, this is stronger one, right? This is the stronger one. So this is the product, this is the reactant. Okay, this one is stronger rather than the reactant. So when you have the stronger product rather than in the reactant, you will release the energy. Okay, you will release energy. More energy release forming CF1 is need to break the FF and then CC again and again. Okay, so the answer, okay, so just type to find the enthalpy change with bond energies. Just remember, break all the bond first, okay, in the reactant, okay, and then minus for the product. Okay, don't do opposite, kind of like the previous one. Okay, in the delta H in heat. Okay, now an OO bond is blah blah blah, then OO bond. Okay, so this kind of concept, uh the concept of double bond and then single bond stuff, how to get this one done. So it's pretty simple. You can answer this question properly if we know, if we understand about covalent bond. Okay, you could approach this by knowing about bond. You should know that you can approach this by considering like single versus double bond, right? A single bond is often the overlap of two hybrid atomic orbitals, such as in like this one, O O. Okay, you will be having kind of like overlap, something like this one. Okay, this one is double, this is the single bond. Okay, single bond. However, if you are having a double bond is often the overlap of two unhybridized, like unhybridization p orbital to form a p bond. So for the OO double bond, it will be kind of like this one. Okay, this one, this one, this one, this one. So this way. Okay, so this is the p bond. Okay, so therefore you can explain like double bond in this part. Oops, in this part it will be like weaker. Okay, double, okay, you can explain how double bond is, I mean, not weaker, I mean stronger than single bond, because there is a additional overlap unhybridized and hybridized p orbital. Okay, So like I mentioned, so not only this one, but it also having kind of like this one as well. Okay, so there are adding overlap of p orbital. Okay, there is overlap in the p orbital. So for single orbit, for single bond, it has kind of like this one. However, if we are having a p bond, we have kind of like adding overlap, so it will be stronger. Okay, so double bond is stronger. Okay, how about the shorter or longer? Obviously, okay, what is not immediately obvious from this, that double bond are shorter than single bond. Okay, single bond tends to, okay, tends to, for the single bond it tends to. So let me think first. Okay, so just remember that double bond tends to shorter rather than single bond. Okay, so the answer will be C. Okay, the answer will be C. Okay, for number 7. Yeah, that's true. Okay, so uh just remember, okay, single just general bond order trend. Okay, for bond order. Okay, single, it will be longer. Okay, okay, higher bond order. Okay, or more bond. Okay, more bonds will be shorter and stronger. This is the key. Higher bond order or many bond, it will be stronger. Okay, why? More bond, this is the concept. More electron share. Electron shares. This is the easy way to memorize. So if we have like more electron, it will nucleus are pulled close together. Okay, it will like shrink together, like pull together. It takes more energy to break a double bond than single bond. Okay, because we need to like spirit much more electron. Okay, atom are placed physically closer with more shell electron pairs. This is the general term. Okay, so just remember, when comparing bond, remember more bonds between two atoms mean they are pulled close together. Okay, making the bond shorter and stronger, harder to break. Okay, so the answer will be C. This is the concept. Or you can explain by using the hybridization concept as well. Okay, so now move on. What is the molecular geometry of CO32? CO32 minus. Okay, remember CO232 minus. Let's take a look at the answer. So C, how many electron? 4, right? Okay. How about the O? O, it has 6. Okay. It has 6. It might be something like this. Might be. I don't know. Right? Might be something like this. So, based on this information, guys, we can rearrange the structure. I mean, the structure, right? The molecular geometry. So C will have kind of like this, and then this. Okay, and then it has O over here. Okay, it has O. Okay, O. Okay, and then it has O as well over here, right? uh, okay, so now, however, we want to make it like overall egg, right? Overall egg, so we can place it also a 2 minus CO2 minus. Oh, we have kind of like adding 2 electrons. Okay, CO3, CO3 to minus. So yeah, this is minus, okay, -2 for C. All right, so based on this information, okay, we have kind of like this, and then lone pair in on the top. So it will be what? Pen, no. Trigonal planar, no. Okay, pen is kind of like this, right? Trigonal planar is kind of like this, okay. And then how about the T shape? T shape, T shape, T shape, kind of like T. This, and then this. Might be, might be. Huh? And then apa? Nggak tahu mah. Udah dimasukin kali. Udah. Okay, now let's see. So you will need to place the atom, right? For the simple ion. So it's kind of like this one. It should be. Or no, no, no. There is no lone pairs, okay? It should be there is no lone pair. Should be like this. So it lose one electron, probably like this one, right? The base one might be like this one. So we can rearrange again, okay? C, and then SO over here, right? Okay, and then has one again. O, okay, okay. And this is -1, -1. Okay, so yes, yes, this one is better. Okay, so now we can see that this one should be trigonal planar. Okay, trigonal planar. Okay, we can also have something good over here. So we want to what we need to do here is C in the center, right? Distribute electrons so each atom get an octet. Okay, this one is the procedure. One double bond to O to single bond to the other two O's. And then these two oxygen get extra lone pairs. So to account for negative charge, okay? So this one and this one, okay? So so the steric number or the the steric number or central atom, okay, over here the central atom is what? So there is three bonding groups and then zero lone pairs, okay? Zero lone pairs. CO3. So the staple Lewis structure is yes. That's true. So C. O. Okay, so what I'm still thinking, like, do we have another way? Just this one. Three bonding around the central carbon, three bonding groups. So the answer is T, right? Yes. What I want to know is, I think I put in something over here. No way. Okay. Let me take a break first. Okay, I back. So like I mentioned, guys, so to determine the was that the geometry, so we need to take a look at the Lewis dot structure. Okay, Lewis dot structure. So and then there is another way to determine that one. I mean, like we need to determine like the steric number. Okay, how many steric number, and then if whether they have a lone pair or not. Okay, so it's kind of like simple, I think. However, we need to like much more understand, right? So let's take a look at based on the steric number, like FSEPR theory, like Vesper theory. So in this case, the steric number is zero, right? The steric number is zero. Okay, so we need to determine the electron domains. In this case, uh, there is a, I mean, three bonding group. Okay, there is a three bonding group, like uh, three bonding group, and then zero lone pair. So the steric number is three. The steric number is three, and then the thing that we want to know that if the steric number is three and then there is no lone pair, okay, it will be like just trigonal planar. Okay, so the electron geometry is trigonal planar, molecular geometry also trigonal planar. So pen it, so for the option 2, pen with the two bond group. Okay, two bond group. Okay, trigonal pyramidal happen with 5. Okay, 5 electron domains, or kind of like PCl5, right? T shape is kind of like with the 3 bond, okay, ring group, and then it has two lone pairs. Okay, so I just want to I mean, we need to take a look at more detail about this one. Okay, so just a brief explanation to get more understanding over here. So if we want to, okay, so now first one, if the static number, okay, 2, it will be pen. Okay, it will be linear. Okay, zero lone pair. Okay, zero lone pair. If the static number is 3, okay, and then no lone pair, it will be trigonal planar. If that one is 1, okay, I think I need to make it smaller. Okay, I make it smaller. Let's do it over here. Okay, so steric number. So if 0, if 1, it will be linear. The lone pair is 0. Okay, this one is lone pair. And then steric number 2, yes, if the steric, this is 2, right? Not just 1. Or should be at least 2. If the steric number is 3 and then linear, it trigonal planar. Okay, so and then I will kind of like make much more like just a visualization, okay, to make it good. Okay, and then trigonal planar is kind of like this, and this. Okay, and then how about if it has one lone pair? If it has one lone pair, so it will be kind of like this, right? And there's lone pair here, and then this, and then this. So it will be pen. Okay, or angular. Okay, it will be pen. Okay, how about the steric number 4? If 0 lone pair, it will be tetrahedral. It will be tetrahedral. How to show it? Kind of like this, and then this. Okay, I just want x, and then x and x. How about if it has 1? It will be kind of like this. Okay, so if 1 is trigonal pyramid, trigonal pyramid, trigonal pyramid, and then trigonal pyramidal is, it will be 5. It's kind of like this. If trigonal pyramidal, this, and then this, and then this, and then this. Okay, so this is trigonal pyramidal. How about the T shape? The T shape is kind of like this. T shape. Okay, the T shape, it will be kind of like this, right? And then it has kind of like this way. Okay, yeah, this is the T shape. And then there is also square octahedral, right? Octahedral, which mean this one, and then this one, this one. Yeah, that's all. That's all for. I mean, we have much more. Hopefully not. They don't test like we have to memorize one by one. No, no, it will be kind of like contradictive. We need to understand the concept, not memorization. But yeah, we just hope that we don't get any kind of like that we don't remember. Okay. Okay. Now let's move on to this one. Which species contain a bond angle less than 120 degree? Okay, less than. This one is 120, I'm pretty sure. Which species contains a bond angle? A bond angle. This one is pen, right? And then this one would be more. And then how about this one? It should be D for the answer probably. So for this one, so NO3 is still trigonal planar, right? Trigonal planar. Because the steric number is 3 and then there is no lone pair. This one as well for the A. And then how about this one? E, steric number is 2, right? The steric number is 2. However, oh, no. The steric number is that 2? No way. No, the steric number is 1, 2, 3, 1, 2, 3, 4, 5. Okay, 5. The steric number over here is 5. However, it will, okay, so this will 180, right? This is a linear, right? Linear. Because it will be linear, so because this one and this way. Okay, so yeah, linear, because it's same with the steric number 2, right? It will be linear. Yeah, that's true. However, it has one lone pair, but the answer will be D. It should be D because the steric number is 4. Okay. However, it has two lone pairs. Okay. However, it has two lone pairs. So 4 and then it has to lone pair, so it will be 109 degree. Okay, 109 degrees. So the answer will be D. All right. So yeah. Okay. We don't need to know everything, but we just need to know, like, okay, just remember like trigonal planar, this one 180, and then trigonal pyramidal, or for this one, right? So it will be 180, and this one is 109.5 for the trigonal pyramidal. Okay. Now, which molecule is nonpolar but contains polar bonds? Which molecule is nonpolar, however contains polar bond? How to get the answer for this question is quite bit uh confusing, right? The question is about, like, which molecule is nonpolar. We know that if we have information for the electronegativity, we good. However, there is no information for this one. So how to solve this problem? So we need to know, okay? We need to know what's the definition of nonpolar itself, okay? We need to know what's the definition of polar itself. Let me bring this one first. Okay. So we need to draw the Lewis structure again. CO2. CO2. Okay. SO2. O2. CHCl2. Okay, now uh and then we need to know the electronegativity and then molecular polarity. However, it's kind of like complicated if we want to know everything from here. I mean, we need to have a simple explanation. Okay, we need to have a simple explanation. Okay, now let's take a look at the Lewis structure. So this one is linear, right? This one linear, this one linear, right? Identical atom. Oh, SO2, no, not linear. This one is bent, right? This one is bent. And then this one is identical atom. And then this one is tetrahedral. Okay? Now, how to get the answer? Okay? Uh, CO is polar bond. Polar bond. Okay? Polar bonds. and then the molecular geometry is linear and symmetric. Okay, so dipoles cancel. Okay, dipoles cancel. So polarity non-polar molecule with polar bonds. Okay, non-polar molecule with polar bonds. The polar with the meaning of polarity. So the correct answer will be A. How about the B? Okay, structure is band. Okay, polarity, polar molecules. Yes, this one is polar molecules. Band, dipoles, but dipole is not canceling out. Okay, dipoles not canceling out. Okay, and then how about the O2? So many concepts we need to learn. Okay, so many concepts we need to learn. Okay, CO is polar bond. Okay, polar bond, because O is more electronegative than C. Okay, how about the B? SO also polar bond, because O also more electronegative than S. And then how about the oxygen O2? This one is not polar bond because identical, so non-polar. Okay, non-polar. So we eliminate for the option C. How about the CH2Cl2? Okay, CH and CCl also polar. Okay, this one is polar. And then now remember, the molecular shape is tetrahedral but not symmetric. Okay, there is a H and then Cl. Okay, because the symmetry, like there is no symmetry, so dipoles do not cancel. So what's the meaning of non-polar but contain polar bonds? The definition of non-polar but contains polar bond is polarity is zero or cancel out. Okay, and but polar bonds. Okay, the D one, the polarity is not zero. I mean, the dipoles is not zero, so we can cancel. We can eliminate for option D. How about the option B? Again, the option B looks like good, right? The symmet looks like symmetry, but not, because this one is bent, kind of like this one. Okay, dipole, so dipole is do not cancel. So because it's bent, the molecule has a net dipole and is polar. This one still polar. The question is which molecule is non-polar, which means we need to know the net the net dipole, it should be zero. The not net dipole should be zero. So only the option A that give us net dipole equals zero. Okay, so this is the reason why. Okay, just remember, if the question is non-polar but contains the polar bond, okay, non-polar is the net dipole is zero. Okay, and yeah, the option C, yes, the option C is non-polar. However, the question is but contains what? The uh contains polar bonds. Okay, so the question is non-polar but contains non-polar. So we need to know which one that polar. However, based on the net dipole, okay, it will be zero. Okay, again, what is the hybridization of two label carbon atoms? So let's take a look at for the next question. Okay, what's the hybridization of two label carbon atoms, C1 and C2? C1 is only contain the single bond. It will be sp3. However, for the C2, it has triple bond, which is just sp. Okay, just remember this one. Okay, just remember this one. So sp3 and ssp. The answer will be C. So remember, if two electrons, okay, two electrons like attach, okay, if electron attach, it will be sp. If 3, it will be sp2. If 4, it will be sp3. So as you can see, guys, there is a 4 electron attach over here, right? 4 electron attach. So sp3. However, for this one, okay, for this one, it only attached to electron. Okay, attached to electron. Okay, for the C2, it only attached to electron. So on C1, it it has a bond to N, bond 3 for H, right? And then C2 as well. Okay, so total attachment is 4 atoms. Okay, no lone pair, so it making 4 single bond. Steric number 4, so hybridization is 4. So C2 bonds to single C1, right? And then N is triple bond. So only two two electron groups, okay, group. Okay, so there just two over here. Okay, so it's only sp. Okay, so steric number just 2 atom. So which one did the best one? The answer will be C. Okay, how many sigma and p bond are in one molecule benzoic acid? Just remember, sigma is only for single bond, and then p only double bond. Let's take a look at this answer. If you see only single bond around a carbon, it's sp3. If you see a double bond, it's probably sp2. If you see triple bond, it's sp. But always count the number of thing attached. Single, double, triple, or lone pairs, because that gives you correct hybridization. Okay. So yeah, that's the good thing that we need to remember. Okay, that's the good thing. Just we need to remember, like, if two electron group, t electron group, four electron group. So two electron group will be sp, three electron group will be sp2, four electron group will be sp3, and then whether atoms or lone pairs. Okay, you need to count for the as well as for the lone pair. So single bond always one sigma bond. Okay, just count. Okay, single is one sigma bond. Okay, and then double, it will be 1p and then plus, okay, 1p plus 1 sigma, and then triple 1 sigma and then 2p. Okay, every bond between atom counts one even in rings. Okay, so now let's take a look at the answer. Okay, let's take a look at the answer. How many sigma and p bond are in the one molecule of benzoic acid? Oh my god, it will be annoying because we need to take a look at one by one. 1 2 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So sigma bond will be 15. How about the p bond? P bond will be 1 2 3 4, only 4. So the answer will be C as well. Will be C. The last one, the molecular orbital for this one and He2 2 plus and then He2 are shown here. What are the bond order of He2 plus and He2? Okay, the bond order. So what's the meaning of the bond order is like how many bonds? Okay, how many bonds? So let's take a look at the question, the answer. So first of all, what we need to know over here is we need to know we need to know like molecular orbital diagram and then definition of or bond order. Okay, so as you can see, guys, the bond order is half. Okay, bond order is half, right? Bonding electron, then anti-bonding. So bond order for the H2 2 plus is binding order is 2, right? So it will be half 2 minus 0, right? So it will be 1. And then let's take a look at for the this one, it will be 2 minus 2, right? So it will be 0. So 1 and 0. It will be T for the answer. Yes, it will be T for the answer. So number of bonding electrons and the number of anti-bonding electrons. So as you can see, guys, the 2 minus 2, okay, and then 2 minus 0. Yeah, so the answer will be T. Okay, that's true. Just remember, bond order is, what's the definition of bond order is number of bonding electron, which is representing by this one, minus not an anti-bonding, then this is half, right, over here, kind of like this one, or yeah, whatever. Okay, should be something like this. Okay, to find bond order, just count the electron in bonding and anti-bonding, subtract and then divide it by 2. Okay, if the bond order is 0, the molecule 1 axis. Remember, if the bond order is 0, Okay, if the bond order is 0, the molecule won't exist. Okay, so if it is one or more, a bond order is formed. Okay, so as we can see, He2, okay, the molecule probably one order, okay, won't exist in the word. Okay, so yeah, all right, we have kind of so many still so many question, but I think like I need to take a rest a little bit, and then we want to start it for the second part, I mean for the second session.